Yes, dear student, till now you have learnt about specific heat, molecular heat capacity of gases and solids, etc. Now we come to new topic, latent heat. And you can say here, change of state is one topic here, change of state. What is that? Actually, generally when we give heat to any body, temperature rises. But there comes a stage, we are heating but temperature is not rising. Generally when we give heat, temperature body increases. But there is a state, there is a position. We are heating but temperature not rising. But what is happening? The state of matter is changing, like a solid melts, liquid boils, etc. So how actually, in case of solids, there is a strong force of attraction between molecules or atoms. We have to, if that melts into liquid, it means the force between molecule has been decreased. And that, how does it decrease? When we heat up a material, molecules take heat energy, start vibrating with large amplitude, and beyond a certain amplitude, that force of attraction become small and that turn into liquid. So we need energy. We need energy to change the state of solid into liquid and liquid into gas. So heat required to change the state of unit mass to change the state of unit mass of a material is solid or liquid. Is called latent heat. Please note it, heat denoted by capital L. We denote by capital L, latent heat. Heat required to change the state of unit mass of matter, material, that is solid or liquid. Sorry. Abhi bhai, 1 minute. Material, the heat required to change the state of unit mass of material at constant temperature. For example, ice melts at 0 degree centigrade, water boils at 100 degree centigrade. Constant temperature is called latent heat. Latent heat. Denoted by capital L. Now latent heat of two types. Number one, latent heat of melting. Latent heat of melting. So who melts? Solid melts. The heat required to melt unit mass of a solid at its melting point. Is called latent heat of latent heat of melting. Denoted by capital L. Again, for example, latent heat of melting of ice is 80 calorie per gram. Joule, you can convert to joule 18 to 4.18 0, 8, 64, 6, 818 or 614, 133. So point here. Some people write it as 335. कुछ लोग इसको 335 जूल पर ग्राम, किलोग्राम लोग 2000. People here are confused also. Sometimes they can call it as latent heat of fusion. यहाँ पर जिक्र करते हैं latent heat of fusion का जिक्र करते हैं लोग बात. Latent heat of fusion. Do you know what is fusion? When liquid molecules come together and make solid, that process is called fusion. So latent heat of fusion means here ice melt by 1 gram ice melt by taking 80 calorie of heat. Then 1 gram water at 0 degree centigrade will become ice by releasing 80 calorie of heat per gram. That we may call as latent heat of fusion. 80 calorie per gram is the heat released or heat released heat released per gram of water at 0 degree centigrade to convert into ice. Well, like that. Both are equal. Latent heat of melting and fusion, the same thing. But in fusion, liquid turns into solid, and in melting, solid turns into liquid. Now, latent heat of boiling. Latent heat of boiling. Or evaporation बोलते हैं, but evaporation take place at any temperature. Boiling takes place at a fixed temperature. Now if water gets spread over your floor, after some time the floor become dry because water has evaporated. I will explain it later, but come to later heat of boiling. The heat required to boil unit mass of liquid at its boiling point. Is called latent heat of boiling. For example, 1 gram of water boils at 100 degrees centigrade by taking nearly 530 calorie of heat, and therefore latent heat of boiling of water, and hence latent heat of boiling of water is 540 calorie per gram at boiling point. When a liquid turns into vapor or gas that needs heat for vaporization or boiling. Vaporization takes place at any temperature. One thing more I will discuss later on. If mass m of liquid of latent heat L boils at its boiling point, then heat required Q is equal to, we write ml. Same true for melting. If m mass of solid melts at melting point, then heat Q is equal to ml. So 1 gram ice take 80 calorie of heat. Now, if you want to convert water into ice, now you have at home refrigerator. You put that into refrigerator, and a refrigerator extract heat from water, and convert that into ice. When you decrease temperature, again you extract heat. In refrigerator, how we are able to reduce the temperature of environment inside? There is a gas which operates at some minus degree temperature, but for evaporation that require heat. So one side of refrigerator we allow the gas to pass at low pressure. The boiling point decrease with decrease of pressure. Then that gas take heat from the surrounding and further evaporate. Initially that was taken in liquid state. Liquid state of gas is allowed to flow from low pressure side to high pressure side, and then take heat, become vapor, and then those vapor that become gas, that gets liquid gas take heat from the surrounding and temperature keep on decreasing. Similarly, in summer season we use pots of soil, मिट्टी के बर्तन का घड़ा होता है, उसमें जब पानी भरते ठंडा हो जाओ. When you put water in pot of soil, मिट्टी के बर्तन, so that water becomes cool. Why? Because molecules have different energy. The molecules having energy larger than other, they come on the surface from where they get evaporated. For evaporation, latent heat will be taken from the container itself. So temperature of that keep on decreasing. In rainy season, this cooling does not take place because in rainy season the air is saturated with vapor and it absorbs no water from the surface. so it does not cool down. So when we take heat from somebody, temperature decreases. So this was about idea of latent heat, of boiling and vaporization. Now I come to the topic, principle of measurement of heat, or principle of measurement of heat, or people may ask you principle of calorimetry. अब ये कैलोरीमीटर वर्ड पहले आ गया. Calorimeter is a device which is used to measure heat. I will discuss what is calorimeter later. So the working principle used to measure heat is based on the fact that when a hot body and a cold body are placed in thermal contact, मैंने यहाँ बाजू लिखा when a hot body and cold body are placed. Body, it may be hot bodies, may be cold bodies also. Contact, then heat flows from hot body to cold body till their temperature becomes same. In this process, heat given by hot body is equal to the heat taken by cold body. यानी कि heat given equal to heat taken. इस तरह से, लेकिन किनकी heat given by hot body is equal to heat taken by the cold body. This is the principle of measurement of heat or thermometry, calorimetry. I should write there principle of thermometry, not calorimetry, sorry. So what is calorimeter? 2 मिनट लगेंगे सिर्फ. What is calorimeter? Calorimeter, device used to measure heat. It is simply a beaker of copper container which is placed inside wooden box. ये वुडन बॉक्स है, some insulation is placed in the gap between the wood and this calorimeter, and here we use a lid, and there is a hole through which we use thermometer here. Thermometer. And another is a stirrer. It is also copper. Cu stirrer. And then we fill 2/3 volume of this with water. This whole system become calorimeter. This whole system become copper stirrer. You know, water is bad control heat. When we put some hot body, water take heat, but heat does not flow in water itself. So we stir the water. So that temperature whole water becomes same. We have taken copper because copper is good conductor, best control heat. Because when we take the rising temperature, we assume that whole mass of copper is at same temperature. Latent specific heat is small. वैसे तो lead has much lower specific heat than copper, but lead is bad conductor. So this whole system is called calorimeter. This is copper container. This is wooden box. This is wooden lid. Thermometer, stirrer. They will together make thermometer. Oh, calorimeter. Remaining topic I will be discussing in next video. Thank you.